All right, let's take a look at a computational approach to evaluating a limit. This problem, we've got the limit as x approaches -1, and we're dealing with a rational function here. The numerator is x squared plus 6x plus 5, and it's divided by x squared minus 3x minus 4. Now, because we're taking the limit of a function at a real number value, we always are hoping for continuity at that real number value. And if we have that, we can plug in the -1 in both, in this case, the numerator and the denominator, get a real number, and be done with our limit. However, when we plug in -1 here, we realize that we get 0 over 0. And in limit speak, that is an indeterminate form, which tells the person doing the problem that we're going to have to do some type of manipulation to determine what the actual behavior is going to be at, in this case, x equals -1. Now, looking at this problem, if I'm plugging -1 into polynomials and I get a 0 for that, I know that x plus 1 is going to be a factor. So I am going to take the limit as x approaches -1. Now my numerator, I'm going to factor it. Because -1 zeroes out that numerator, I know that x plus 1 is going to be a factor. So the other factor to get the x squared plus 6x plus 5 is going to be x plus 5. Now we're going to divide that by, and again, same rationale. If I know that -1 zeroes out my denominator here, that means that x plus 1 is going to be a factor. And in this case, if x plus 1 is a factor, we can see that x minus 4 is the other factor. So now that we've factored both the numerator and the denominator, we realize that they have a common factor involved here, the binomial of x plus 1. So we can cancel those out and be left with our limit as x approaches -1 of our numerators now x plus 5, our denominators x minus 4. At this point, when we plug in that -1, we don't get 0 over 0. So I'm going to drop my limit notation. I'm going to plug in that -1. Or in other words, I'm going to directly substitute -1 into the function. So I get 4 in the numerator divided by -1 minus 4 is -5. 4 divided by -5, or usually we would say that's -4/5. And that is the real number answer to that limit problem.